Space goes. We are going to draw a curve in three-dimensional space. It's a curve because we no longer have functions, right? We don't have y equals f of x, but we have component functions. X-axis, y, z. We shall try. Let's keep it simple. T. I said simple, right? Sine t. T plus 1. Good. Make sure your calculator is in radians mode. And you will see as to why we call it a space curve. Easy numbers to pick. In our case, any thoughts as to what the easy numbers are? 1, okay, I have a trigonometric function. I have a trigonometric function. Anytime we have trigonometric functions, it all goes back to one guy. Pythagoras. You know, going in a circle, it would be easier if I simply picked 0, pi, 2 pi, 3 pi, just like last time. Yes? Okay, I'm going to put 0. Yes. I'm being blown away by calculus. 10.
I have a feeling if you are or if you are not, if you were a father, you would make great dad jokes.
That is very true, but I'm not. I'm very good at dad jokes. There's the y-axis, it's not a big deal. The other two will end up having large numbers. Okay, that's good enough, I guess. T is 0, we have 0, sine 0, 0, get 1. Yes? So the starting point, in my case, I'm limiting it from 0 and beyond. So starting point when t is 0, I'm at 0, 0, 1. Actually, here. Good. When t equals, we can also do pi over 2. Yes? I do pi over 2. I will get pi over 2. What is sine pi over 2? 1. Pi over 2 plus 1, 3 pi over 2. We can approximate pi over 2, 1.5.
How is it 3 pi over 2? Would it be 3 plus 5? When you just do pi
Bad math. Okay. Pi over 2 plus 1. Thinking pi over 2 plus pi.
I said I want now. I know I talk 2 is so hard.
So t pi over 2, 1.57 over here, and then 1, so we're going to go over there, yes, pi over 2 plus 1 to 0.57, right there. Agree? So I'm going to put a point in space. Of course, we can't see it. So from here to there, and there to there, there, tracing it in that direction. So that. And pi, t would simply be pi, sine pi, 0, t plus 1, pi plus 1. So over to 3.14 here, y is 0. So where will I go if y is 0? Come again?
You would stay on
So stay right there because when y is 0, we are in this plane, correct? The exit plane. So here and pi plus 1, 4.14. So from here going up there, but that's the plane. Good. So
Would that leave behind or up in front?
come again?
Like, would it be behind the z-axis? No, it wouldn't, never mind.
No. Let's see what happens when we go to 2 pi. We've already seen what happened. Well, let's do pi over 2 then, excuse me, 3 pi over 2, then 2 pi. 3 pi over 2, we will have 3 pi over 2. What is sine 3 pi over 2? 1.
Or it's off. There.
Negative 1 and 3 pi over 2 plus 1. This time I received my brain immediately went for 5 pi over 2. So 1.5 pi, so 3.1492, so somewhere over here. So over there, down to negative 1, right? And then I go back up to 4 something plus 1, which is 5. Right there. Good. So I must have turned around. Agreed? So one, oh, right. 4 minus 1, it'll be behind here somewhere. Because I'm at 4 plus 3 pi over 2 approximately 3 times 3.14, 9.3 over 2, 4.6 something over here, plus 1, 5 point something. There, z-axis. However, I need to satisfy minus 1 and 4. Yes, I come this way over to minus 1. Or is it plus 1? Oh, minus 1.
Those are the absolute.
Yeah. So minus 4 this way, then minus 1 over there, is and up over there. I guess it would come something like that. Yes,
curl towards us, like a 3D movie.
Yeah, it has to loop. Anytime you have a sign, it's going to loop. I'll do one more and then we can stop. You can see why this is getting difficult.
Or we have like a computer touch screen right there, we can just like shift it.
Right. Then it'll be, I did look up GeoGebra, wasn't it? Fine. You can check that website out, the one that I showed a long time ago. So this would be 2 pi, sine 2 pi is 0, 2 pi plus 1, 2 pi is 6.28 approximately. So I come this way here, 0, I stay there, and 2 pi plus 1 again, 7 point something in that space. Yes. Good. Now I'm not sure if it's going to trace in an exact way. It has to, because I have a sign there, so it's periodic. So going to come there. Yes. If I repeat this process, take a guess. How would things be going?
It would be going up and stuff.
It's probably going. Yes. Periodic. So anytime you have signs, space signs, you will have loops. And in drawing a space curve, you have to denote where things start and where it's going to end. They're going this way, that way, that way, there, 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 there. Okay. So if you recognize one period, then you can extend it to n periods. The repetitions will be very similar.
Look at it a certain way, you can see the sign.
Yeah. Yep. I didn't do a bad job. Good. So that is what we call a space curve.